So I was working on the team that was responsible for making the weather forecast for the Mars landing.
Can you imagine like your performance review if you got it wrong?
Yeah. They're like, well, it was nice working with you.
You cost us billions of dollars.
So you're going to spend more time with your family and focus on philanthropy, okay?
I think NASA's a little more forgiving than that. Hi, everyone. I'm Jolie Hales.
And I'm Ernest DeLeon.
And welcome to the Big Compute Podcast. Here we celebrate innovation in a world of virtually unlimited compute, and we do it one important story at a time. We talk about the stories behind scientists and engineers who are embracing the power of high-performance computing to better the lives of all of us.
From the products we use every day to the technology of tomorrow, computational engineering plays a direct role in making it all happen, whether people know it or not.
Hey, Ernest, question for you.
Go for it.
Have you ever seen a UFO? Or I guess I should use the newer preferred term, unexplained aerial phenomena, or UAP, I guess they call it.
So the short answer is yes, I have seen.
Ooh.
And actually more than once.
What?
Yeah, but, I have to caveat that something was flying around and I didn't know what it was, and it did not look like a typical aircraft. But it wasn't like in the sense of like, hey, this thing was darting around at ridiculous speeds and then, plowed itself into an ocean like you'll see on some of these things. I've never seen that.
You just saw things in the sky that you as a civilian didn't recognize.
Right. And it happens frequently out in West Texas. There's a little town there named Marfa that's pretty popular in the, let's just call it the UFO circles.
First spotted by settlers back in the 1880s, the Marfa lights have been documented by photographers, chased by fighter pilots, and hunted by scientists. But so far, they remain a mystery.
Yeah, I've seen them when passing back and forth through West Texas, and every time I see it, I'm like, it's probably a military aircraft, but whatever.
Yeah, that makes sense. That makes sense.
But how about you? Have you ever seen one?
Okay, so I have, actually. I'll tell you the story. Back when I was a teenager in the 1990s, to age myself, I was riding in the front passenger seat of our family minivan, and then my mom was driving. And I remember it very specifically. We're on a street called Cherry Lane in Layton, Utah, and we were driving east on that road toward the mountains, so we could see the mountains in front of us. And it was during the middle of the day. So this is northern Utah, middle of the day, driving in this minivan. And I remember we were just having a normal conversation. And then as we were in the middle of this conversation, I suddenly saw this bright light zip across the blue sky above the tallest mountain peak. And then it stopped in midair. And it immediately caught my attention, as you might imagine, because it was so bright and big enough to stand out in the middle of the day above this tall mountain range, right?
Right.
And the way that northern Utah is, it's like a valley, and then all of a sudden the mountains just jet out from this valley. So we were on the flatter part, and this light appeared above this range. Now, I do have to say, we lived next to an Air Force base in northern Utah. So it was very common for jets to fly around. And as a theater performer, even, we would often have to stop mid-song or mid-act to pause as these jets would fly over because they were so loud. And then we'd resume once the jet disappeared, into the distance. It was just very common for growing up there. But this light, this thing in the sky, was just totally different. What made it so different was in the way that it moved. It suddenly started zipping around kind of like a hummingbird. It paused and changed directions multiple times. And then after doing this hummingbird flying thing across the sky over the mountains, it then suddenly dove down super fast and disappeared behind the mountains. And it was so bizarre and unfamiliar to me that I honestly got the chills. And right after it disappeared, my mom said, "Oh my gosh, did you just see that?" So that confirmed that whatever it was hadn't been like in Phenomenon, some brain tumor or something that only I could see this light. My mother had seen it as well.
Yeah, if someone else saw it at the same time you did, unless you're under the influence of certain chemicals, I think it's probably valid that it was there.
It certainly seemed like it.
And that's really the telling thing, right? In your example there, the ability to abruptly change direction at fast speeds, which our most modern aircraft cannot do. Right. Our technology cannot ignore gravity. But it seems like some of these UFOs can.
Mm-hmm.
And I will say that most of what people report as UFOs are, in fact, just experimental aircraft. They're not necessarily of alien origin.
Right. And to your point, so I'm a person who believes that everything has a rational explanation, right? I mean, I host a technology and science podcast. I tend to want evidence before I jump to any conclusions. And I like to consider all the different possibilities. But that's also what made this light so fascinating for me, because I couldn't find a rational explanation for what my mom and I had seen. I mean, it obviously wasn't something I saw in my head because my mom had also witnessed it. It didn't move like any machine or airplane or weather balloon or anything I could think of. It wasn't a reflection on the dash, and drones as we have them today weren't a thing back then. And it would have had to be this like massive drone that defied the laws of physics. So I don't know what it was, but I'll honestly never forget it. And to this day, I still have no idea, nor have I found any clue leading me to know what it was that I saw. And I never saw anything like it again.
This seems like it should have been an episode on the X-Files. Another gem in terms of television film.
Yeah, kind of like the X-Files. It felt very X-File-ish back then. I think that's actually the time when the X-Files were really popular, too.
It was.
It was in the 90s. Yeah.
Absolutely.
So maybe it was subconsciously influential. Anyway, so this is interesting. So as I was doing research for this episode just a few days ago, I came across this list that the Pentagon has actually released. And it outlines characteristics that are common of UFOs reported in both military and civilian sightings. So that obviously got me curious to see how it compared to this unidentified object that I saw.
And was it similar?
That's the interesting thing. It was almost like the Pentagon had just written down the characteristics of the craft that I saw, or if it was a craft. So this list that they have includes the craft appearing to defy the laws of physics, stopping in midair and reversing direction without inertial effects, descending rapidly in an instant, exceeding the speed of sound without generating a sonic boom. I mean, that honestly was what I saw.
And that makes perfect sense if you think about it. The Pentagon is not only aware of its own experimental aircraft, but also it's keenly aware of physics, right?
Mm-hmm.
They would only report on the phenomena that are not their own experimental projects for obvious reasons. And these things would have to seem to defy the laws of physics, right? So it would be something that is of concern to them with the current knowledge set they have, as opposed to the general public, which knows nothing as to what the Pentagon's doing and will report everything, right? So
yeah, I have no idea. I just find it a fascinating memory more than anything else. And I mean, if you haven't noticed, UFOs are all the rage right now, like in publications and conversations, as more U.S. government information on the subject is being released. And apparently there's more that's going to be released anytime now.
Yes.
And it's crazy to think about what these unidentified objects that people have reported might actually be. In fact, if you haven't seen it, there's a video that's been released by the government showing one such UFO that was captured on video by U.S. Navy pilot jet dash cams. Apparently our jets also have dash cams. Yeah. Have you seen this video?
I actually watched it because you put it in the script.
Yay!
And it's interesting that you put this in here because I had heard about this on the news, right? I hadn't actually seen the clip though until today, but I have a real good friend of mine who was a naval intelligence officer, and I immediately messaged him and said, "Hey, what do you know about this?" And his response is nothing. So
like nothing, like I can't tell you?
Well, that's kind of the joke, right? Like I don't know which one it is. Like he still has active clearance. I do not. But whenever I see clips of UFO footage in general, they're interesting to me, of course, but I really love to hear the pilots describe this because they describe it in their parlance because they fly all the time, right? So they know exactly what the limits of their aircraft. So when they're surprised or shocked, you know that whatever that is something
exactly
abnormal or out of the ordinary, and it's usually because they see it do something like defying gravity that their aircraft cannot do.
Yes, and I think that's what makes this clip so interesting to the public is because, yes, it is a fascinating object that we see, but honestly, you could tell me that there's a completely normal explanation for it, and I'd be like, oh, okay. And then I'd move on. But the fact that the pilots are reacting the way that they're reacting tells me that, no, this is not something in the norm.
There's a whole fleet of them. Look on the ASA. My gosh. They're all going against the wind. The wind's 120 knots from the west. Look at that thing, dude. Well, if there's like... Look at that thing. It's rotating.
I mean, could you imagine if you were a pilot, there's like a sea of these things coming at you?
I would pee my pants.
I would book it out of there as fast as I could.
Yeah, it's really interesting clip. We'll put it on bigcompute.org for people to watch it if they haven't seen it. So this got me down the UFO rabbit hole, and I looked up statistics on the number of UFO sightings reported over the last few decades because I was curious if the wide adoption of smartphones would have potentially caused a decline in these UFO reports. Because, I mean, people catch all kinds of crazy crap on video these days since everyone has a video camera in their pocket now. So wouldn't it make sense that as smartphone usage increased, we'd either start seeing more video footage to go along with these claims of UFOs, or that these claims would potentially even decrease because it's harder to just make something up that people won't really believe if you don't show video evidence?
While I definitely think that, you know, since more people have cameras with them all the time, there would be an increase. But then again, like I said, you never know. I'm curious to hear where your statistics led you on this.
Yeah, there's actually an organization called the National UFO Reporting Center, and they basically track all UFO sightings in the world.
Did you know just about an hour west of Spokane in Harrington, there is a National UFO Reporting Center?
I had no idea what it was. All I saw was something just go real fast.
Well, we saw it right through the trees, kind of approached from over that direction.
Like 6 bright orange color light.
If there's even a shard of a possibility that this is true, it is the biggest scientific question that has ever confronted mankind.
According to their reports, which the earliest record I could find from them was in 1990, and that first year, they reported that there were 319 reported UFO sightings in that year, 1990. And then from there, that number gradually climbs, and then it hits 3,000 sightings in the year 2000. So there's an increase of 10 times over one decade, right? Then that number continuously climbs to around 5,000 reported sightings in 2010. So it almost doubles, not quite. And then the first iPhone came out in
2007.
How did you know, Ernest? You don't know anything about iPhone.
Because I watched Steve do it live.
From the front row of the auditorium.
I wish I had been in the front row, but I was a buyer day one, obviously, even though it was a pretty rickety device back then. I believed. But hey, you know what? My belief panned out. There are plenty of people who bought Google Glass with the same kind of fervor. Where is that right now? That's all I'm going to say.
It's going to make a comeback, Ernest.
They've been saying that. It's just like every year's the year of the Linux desktop. Oh, man.
Anyway, yes, the iPhone was first released in 2007, like you said, but then smartphone usage really started to take off around 2012.
Yep.
And then the highest reported number of UFO sightings in a given year, according to this data, was actually in the year 2014. Where it hit a peak of 8,736 UFO sightings that were reported in that year.
Yeah, and one thing I'll point out is remember that these are just reports. So the numbers are kind of, to me, low because 8,700, like I feel like when you take the entirety of the world and an entire year into account, that there would be much more than that. We would be in like the hundreds of thousands, not 8,000.
I don't know. And then just 4 years later, that drops down to 3,500-ish in 2018. So it drops by more than half over just 4 years. And that's around the same time that social media really started to boom and people really started to post a lot more videos and photographs on the internet.
Yeah, so what you're saying is the meme culture destroyed the UFO culture. Is what you're saying.
Very possibly.
That's an interesting point. But, you know, there's a couple of things, right? So you mentioned in your story earlier that you didn't report this, right?
Yeah.
And I've seen UFOs roughly a handful of times. I don't know the exact number, right? Again, while I was out in West Texas, I never reported any one of those. Not because I thought people would think I'm crazy, but it was just one of those, like, I guess I'm one of those people that just believes that they're here anyway, and it doesn't bother me. So
no way. You believe that there's aliens here?
Oh, yeah. I believe that they've been here for a long time.
Really?
For sure, longer than humans have been a species as we are today.
Wait, do you think that they look like tell me your theory, so we can't just brush by this.
I have no idea what they look like. I've just, it's one of those things where statistically there has to be other life in the universe, right? And then
right, I agree with you there.
Also, statistically, there has to be more advanced life than us.
Yes.
And if a common theory is that the Big Bang happened and the universe is ever expanding, it would make sense that if the same set of conditions that resulted in intelligence sprouting on Earth could happen anywhere, then the galaxies and planets farthest out that were like the first that came out of the Big Bang would have the most advanced civilizations. And
that makes sense. But do you think advanced enough to travel billions of light years to our planet?
That's the thing. My suspicion, again, this is entirely theoretical physics. It's not any kind of proven stuff yet. My suspicion is that you get to a point where it's no longer an issue of traveling.
Oh.
You are not going from point A to point B. You're actually bending space-time and making those 2 points converge, right?
Oh my gosh.
That's a completely different way of looking at it. And in that context, that means you can go anywhere in the universe anytime you want, almost instantaneously. The caveat there is that no matter how you try to approach that problem, the power required to do it, the energy required to do it is massive, right? So my thought is that they've been around for a very, very long time. And like I said, if I happen to see something, great. I'm not going to call some official organization. Now, if I actually saw one of these things land and things get out of it,
I would die.
Then I would call somebody and report that, right? That's a different scenario. That's not like I saw something fly around for a minute or two and then I never saw it again.
All right. Well, when I finish my second master's in theoretical physics, I'll contribute more to this conversation. But let it be stated here, you heard it. Ernest believes that aliens walk among us. And maybe that's because maybe Ernest is an alien.
It's possible. And I wouldn't say that I believe they walk among us. I know that there are people
you just believe that they're somewhere on Earth.
I believe that they come around from time to time. They come around, look at what's happening, see that there hasn't been much progress in the last 1,000 years, and then take off.
They leave disappointed.
Right, exactly. And their thought is like, observe them from a distance, right? But don't engage them directly because you will essentially break their worldview. And that creates a problem. So I think the cases where we supposedly have crashed craft or whatever are the accidents.
Like Will Smith punching the alien.
Welcome to Earth.
Okay, but there is more with the statistics that I was looking at. So while the numbers that we've been talking about seem to kind of potentially support my hypothesis about smartphones maybe killing off UFO sightings, then the numbers did something interesting after that year, 2018. They kind of did this about face, and then they jumped again over the last couple years, hitting 7,267 sightings last year in 2020, which was the pandemic year. And that's close to the highest number reported in a given year since 1990. So I don't know what that means. This is just one part of the data that I found, but it is interesting to consider nonetheless, I would say.
Yeah, if I had to offer a guess, it would be that because of the pandemic in 2020, more people were trapped at home. They had a lot more time on their hands to be out in nature, right? And maybe that's why they saw more things.
So going back to whatever the heck it was that I saw in the sky in the 1990s, again, I believe that there must be some kind of rational explanation for what I saw. I just don't know what it was. Was it some government device that I know nothing about? I mean, I guarantee there are devices utilized by our government that I'm not privy to, though I wouldn't think that we had the technological capability to create the kind of physics-defining movement I saw in that craft way back when, but who knows? Or could it have been something extraterrestrial like you've been talking about? I mean, is there the statistical probability that life exists somewhere else in this universe? I'm with you on that. I totally think so. Does that mean that they visited Earth? I don't know. I can't say for sure. I don't really believe that, but I'm open to it.
It's just a gut feeling, right? No one can prove that yet. Like, we have data, we have pictures and whatnot, but until someone has met one in person and kind of bring them on TV, it's going to be very hard to say we have definitive proof, right? So it's just kind of a theory.
And honestly, we could do an entire episode on UFOs and it would be incredibly fascinating, though I'm not sure what the big compute angle would be. So if anyone knows a scientist or an engineer out there who is using supercomputing to study UFOs, please reach out.
There has to be somebody doing it.
There has to be. And while UFOs are a mystery, the idea of life existing on other planets is honestly not far-fetched for scientists who are in the business of studying what lies out there in the universe. In fact, let's move away from the fantastical and onto something a bit more scientific, because honestly, NASA probably won't appreciate this direct association with UFO sightings.
Some there might, but I think the administration will not.
Yeah. So beyond all of the UFO reporting, there are actual scientists working at NASA right now with a primary goal of learning if there is or has been life on other planets. And that includes our red rock neighbor, Mars.
I think as a whole, NASA is very hopeful that there might still be evidence of past life on Mars.
That's the voice of Michael Mischna.
I'm a scientist at the Jet Propulsion Laboratory, which is a NASA center in Pasadena, California.
Specifically, he's
the Associate Directorate Scientist for the Planetary Science Directorate.
For JPL, or the Jet Propulsion Laboratory, owned by that little company called, I don't know if you've heard of them, NASA. So he works with all of the planetary science missions, including Mars.
The recent missions that we've sent, like the Mars Science Laboratory and Perseverance, are designed to look for habitable environments, what we call habitable environments, meaning areas that have the proper energy sources, be it chemical, sunlight, or what have you, the presence of nutrients that life could survive on, and the presence of water. Because on Earth, all life as we know it requires water at some point in its life cycle. So our expectation is that ice or water on Mars would be necessary for life on Mars to exist.
This isn't science fiction. Scientists actually believe it's possible that life could have existed on Mars at some point, and they're trying to find any evidence that that's the case. But before we dive deeper into Michael's research, let's give ourselves a grade school refresher on Mars, which means we need some good Mars music.
Is that what that is?
It's perfect, right?
Oh, man, this is so bad.
Okay. That doesn't work. How about something like this?
This is much better.
We'll go with this. Okay, so we all know what Mars looks like from awesome space pictures, right? Red, dry rock, sand everywhere. And as far as size goes, Mars is about half the size of Earth by diameter and about twice the size of our moon. And Earth has a lot in common with Mars. Earth and Mars both have a similar axis tilt, with Earth at 23 degrees and Mars just above 25 degrees, which contributes to both planets having 4 seasons and temperature variations. And both are terrestrial planets, or rocky planets, with an atmosphere, crust, mantle, and core.
As opposed to a gaseous planet like Saturn or Jupiter.
Right. And so far, all the rocks and minerals that have been found on Mars can also be found on Earth. And as far as age goes, scientists believe that Earth is around 4.5 billion years old, and Mars is around 4.6 billion years old, which means that basically the galaxy got pregnant again with Earth soon after Mars was born, and then they grew up close in age and next to each other in orbit. So there's probably some sibling fights and whatnot, I imagine.
Right, and that's why there's a lot of value in studying Mars, because although it is different from Earth, it is possible that at one point it was very similar, and we can probably pick up a lot of clues from studying that planet as to what will happen to Earth in the next 100 million years, give or take.
But there are clearly some major differences between Earth and Mars, too. And while we're both next to each other in the solar system, Mars is much further away at an average of 142 million miles from the sun, when compared to Earth's 93 million miles from the sun on average. which contributes to generally colder temperatures, as you might imagine, on the surface of Mars, although not as different as one might think. In fact, the temperature range on the surface of Mars is negative 284 degrees Fahrenheit to 86 degrees Fahrenheit, or negative 140 Celsius to 30 degrees Celsius, which, I don't know, 86 degrees Fahrenheit sounds kind of comfortable, but apparently it wouldn't be.
It would be a matter of minutes before you were beyond roasted. It would be incredibly painful after just a couple of minutes, I think.
Even though Mars can get up to 86 degrees Fahrenheit, its average temperature is negative 81 degrees. So it's well beyond freezing most of the time. And despite the fact that it's freezing, a human body would almost instantly burn to a crisp on Mars because the atmosphere is incredibly thin with no ozone layer to protect anything on its surface from the sun's UV rays. Which, I don't know, it kind of reminds me of, do you know what I'm talking about? It reminds me of that scene in Indiana Jones Raiders of the Lost Ark where that guy's face melts.
Another great film, second only to the Crystal Skulls.
Is that the new one?
That's the last one, yeah.
Oh, that's so bad. What is with your horrible taste in movies?
I love the bad ones. It's just, I don't like it when they're like mediocre bad. Like, you have to be so bad you're good or actually a good movie.
Mars today is an extremely harsh environment for life. There's so much ultraviolet radiation that hits the surface because Mars doesn't have an ozone layer like the Earth does. It has a very thin atmosphere which doesn't really protect the surface. So on Earth, that's why we put sunscreen on, is to avoid cancer and other, negative things to our bodies. On Mars, it's like going out in the desert in the middle of the summer on a sunny day times 100. It's just incredibly unpleasant for life to survive in such a harsh environment.
So finding current life in this kind of atmosphere is incredibly unlikely.
Personally, I don't think there's going to be anything beyond some type of microorganism on Mars, if we find anything at all.
Radiation isn't the only issue making it unlikely that life exists on the red planet today, obviously. I mean, while Earth's atmosphere consists of 78% nitrogen and 21% oxygen, which is necessary for us to, breathe, Mars' atmosphere is almost completely carbon dioxide, which, causes quick collapse, coma, and death.
And I think it's important to point out that because we're humans who live on Earth, a lot of the way we look at things is from a very Earth-centric viewpoint. Mm-hmm. So we're looking for life on other planets similar to what we have on Earth, which would mean carbon-based, you need water, and all these kinds of things. But just know that there are other scientists out there who are looking at the possibility of life that is different, that, for example, might live off of methane, might live off of other gases, or don't need oxygen, or don't need hydrogen and oxygen, right? Or water in that case. Of course, it's all theoretical. No one's, saying that this stuff exists, but it's a possibility that there are life forms that just don't need what we do to survive.
But all of this doesn't mean that life has never existed on Mars. In fact, according to NASA's website, they say, quote, scientists think that Mars may have had a thicker atmosphere early in its history. And data from NASA spacecraft indicate that Mars has lost significant amounts of its atmosphere through time, close quote. And they also say that while Mars may be a cold, dry, barren place, it may have once been this warm and wet place.
Yeah, and being that it's 4.6 billion years old, who knows what it was like during the entire time before it was observable by us.
Exactly.
If anything, we'd need to do some serious archaeology to figure out a lot more of the history. Because right now and I say this tongue in cheek, we are literally scratching the surface.
But one reason scientists wonder about life having existed on the red planet is because there has been evidence discovered of the past existence of something quite essential to life.
Water.
Exactly. Liquid water specifically. In fact, as many of our listeners probably know, there is water on Mars today. It's just frozen in the polar caps or like ice buried beneath the surface. Basically, surface pressure and cold temperatures prevent water from existing on the planet in liquid form on the surface. So there's no rivers, lakes, seas, just dry, barren rock as far as the eye can see. If the eye wouldn't immediately be burned to a crisp from radiation.
For 40 or 50 years, we've really seen things on Mars from spacecraft that we couldn't easily explain. What we've seen has been evidence of liquid water or some liquid that has carved out features in the surface. We see evidence of, for example, dry riverbeds, old paleo lakes from billions of years ago, the effects of catastrophic floods that have really etched out and carved out canyons and channels all across the planet. But if you look at Mars today, you see no liquid water. You see no liquid of any kind. And this has really been one of the fundamental scientific mysteries about Mars. And this is dated back to the 1970s, when the Viking spacecraft in the mid-1970s got to Mars and started sending back these really detailed pictures. We simply couldn't explain what happened to all of that water.
So we know that there was water on the planet once. It's just not there anymore.
Right. But if water existed, that certainly amps up the chances that life as we understand it may have also existed at one point on that planet.
We're continuing to look, but we haven't found any conclusive evidence to suggest that there was life. But we have found plenty of places where life might have been able to survive.
And it's that possibility that fuels the search for signs of past life on Mars. But all of this brings us back to Michael's research. While we've seen evidence that liquid water must have existed on the red planet at some point in history, the question was, how?
The scientific community has spent a good deal of time trying to come up with different hypotheses that could have explained how a planet could have had a lot of water a long time ago, and then today be not only very, very dry, but also extremely cold. Mars today is far too cold most of the time to allow for liquid water on the surface. And the surface pressure is too low to allow liquid water on the surface. It just doesn't make sense.
Scientists have proposed a number of different theories, but then none of them really panned out.
For a long time, people thought that perhaps Mars had a much thicker atmosphere, made up of various gases, carbon dioxide, for example, maybe other trace gases, things like sulfur dioxide or methane. And as a combination of these gases could have acted as sort of a very impactful greenhouse atmosphere. In fact, Carl Sagan back in the early 1980s hypothesized that some trace gases like ammonia might have actually been in the atmosphere and reflected back some of the infrared radiation that is basically responsible for the greenhouse effect. And so it's a very popular idea, but it never quite worked. You could never quite get temperatures that were warm enough, and you could never quite explain just all of the geological features that you saw with this explanation of just having a warmer, thicker atmosphere.
And so scientists began to test these various theories by modeling them computationally. What if the atmosphere is like this? And what if there's this much liquid water here or here on the planet? What would that do to the temperature?
You can sort of establish on what we call, the back of the envelope calculation, how much of a certain gas you might think would be in the atmosphere. So you could pick, say 1 part per million of the atmosphere might be methane. So a really small methane or ammonia, and it's a really small amount. You then have laboratory studies which tell you just how much radiation methane or ammonia can absorb and then emit back to the surface. Then you can run climate models that incorporate all of that information. And the climate models will tell you what the temperature of the surface would be if you added a certain amount of this gas or a certain amount of that gas.
But the results of these models never really matched up.
It just never quite all fit together.
So there was this dilemma. We knew that there was all this liquid water on this dry planet in the past, but with the atmosphere and temperatures and conditions of Mars being what they are, scientists couldn't figure out how these rivers and lakes and possibly even an ocean could have ever been possible.
It wasn't as if the planet was just always this swamp world and then something happened and it dried out. The water on Mars kind of came and went, it seems. The geology of the planet shows many episodes of the planet getting wet and then drying out, and then getting wet and then drying out. And so we needed to figure something out that would allow this to happen on the planet.
And so a study was born.
I think this is that point where NASA took to putting the scientific method to the test.
Yeah, so a team of 4 scientists, which included our interviewee, Michael Mischna, they got together to test a new hypothesis. And that was led by
Edwin Kite, he's over at the University of Chicago.
With
Liam Steele from the University of Chicago and Mark Richardson, who works for a company in Arizona called Aeolus Research.
Michael wanted to make sure that credit was given where credit was due.
They are the brilliance behind a lot of this work. So I felt privileged to be able to work with them.
I love how humble so many scientists are. I mean, there are all these like ridiculous celebrities famous for doing dumb crap on Instagram or something or on TV. And some of them are so into themselves. But then you have these scientists who are actually changing the world and even discovering the truth of other worlds in this case. And I find that they're often some of the most humble people I've ever met, which is pretty admirable, if you ask me.
I think that's because coming up in the, science and engineering world, you quickly realize that there's more out there that you don't know than you do know.
It's like the more I learn, the more I realize, the less I know.
And you're constantly trying to learn more, but that the process itself tells you that you're never going to be able to know everything, right? You're never going to be an expert in the purest of senses. So it's kind of humbling by nature. You know that you're going up against something much bigger than yourself. You're investigating something much bigger than yourself.
That's a really good way to put it. I mean, imagine actually working for NASA that explores space. From supersonic jets to personalized medicine, industry leaders are turning to Rescale to power science and engineering breakthroughs. Rescale is a full-stack automation solution for hybrid cloud that helps IT and HPC leaders deliver intelligent computing as a service and enables the enterprise transformation to digital R&D. As a proud sponsor of the Big Compute podcast, Rescale would especially like to say thank you to all the scientists and engineers out there who are working to make a difference for all of us. Rescale, intelligent computing for digital R&D. Learn more at rescale.com/BC podcast. So Edwin, Michael, Liam, and Mark took a look at previous research that had not quite hit the target. And then they built a new hypothesis, a new explanation as to how the surface of Mars could ever have been warm enough to sustain liquid water.
It was an incredibly counterintuitive idea that came out. We think of water vapor in the atmospheric community as being a really strong greenhouse gas, meaning just like carbon dioxide in the atmosphere, how it warms the surface. Water vapor is actually a much better greenhouse gas. It would warm a planet much more so than carbon dioxide. In fact, on Earth, most of the greenhouse warming that we experience is from water vapor. It's not from carbon dioxide. So we thought, okay, well, on Mars, if we want Mars to get as warm as possible, we just need to pump as much water into the atmosphere as possible. And this is what people had been doing for decades. And they never got there. It never got warm enough.
In fact, when simulations modeled water being pumped into Mars' atmosphere, it created these big, bright, puffy cumulus clouds in the sky, which were not good at warming the planet and keeping the warm air in that atmosphere. So the result was this planet that was still too cold for liquid water. So that clearly wasn't the answer. It wasn't working. And since these models weren't able to explain the clear signs of past rivers and past lakes, Michael's team decided to go in the completely opposite direction.
The counterintuitive aspect of our work was that what if we made the planet dry instead of wet? So what if we took out all of this water vapor in the atmosphere and we got rid of most of the water on the surface? How would that impact the atmosphere?
So they ran climate models of a dry Mars to see what would happen.
It turns out that you can get much warmer surface temperatures by doing that. And the reason is because just like on Earth, you get the most warming out of clouds that are very high in the atmosphere, clouds that are very cold. And when we look up and we see those fair weather cirrus clouds, those wispy, ice crystal-y type of clouds, those clouds are actually much better at reflecting heat back down to the surface than the puffy, big, thick cumulus clouds. So getting a lot of those high, cold clouds is a much better way to go. That requires, though, that we get rid of most of the water on the surface, because that water on the surface is just going to produce those big, thick, low clouds, which don't warm.
By running their climate model with ice in restricted locations just near the South Pole and just in very high topographic areas, Michael's team found that there was just enough water rising up from those locations that would get just cold enough to freeze and then create these high, wispy kind of clouds that then generated a lot of warming on Mars' surface below.
Absolutely fascinating.
So it was like, oh my gosh, this is not something anyone had expected. You'd think you want to get as much water in the atmosphere, but the answer is no, you want to get just a little bit. And that's what the ultimate result of our study was that a very arid Mars, a very dry Mars, is actually better for getting warm surface conditions to allow liquid water to form.
So it turns out that Mars may have been wet because it was actually dry.
So did they run these models on NASA supercomputers?
They did, actually. Well, at least in part.
The one that I ran is actually a supercomputer that's operated by NASA up at the Ames Research Center here in California, up in the Bay Area. And it's the 25th largest computer in the world. It has about 250,000 cores on it.
I believe the supercomputer is called Pleiades, and it's currently ranked number 46 on the top 500 list. So, a very capable machine, I'd say.
And then the second computer is one that is operated by the University of Chicago. It's a bit smaller. It's only got 16,000 cores in it.
And that supercomputer is called Midway 2. And as far as software goes,
the model that we use, the climate model, is actually based on an Earth weather forecasting model called the Weather Research and Forecasting Model, or the WRF model.
WRF being WRF, which is widely used in weather forecasting, or at least the Earth version of WRF is widely used in Earth weather forecasting.
A group led by Mark Richardson, who's one of the authors on this paper, about 15 years ago, took that WRF model and made it generic enough that it could be used on different planets, for different planets' atmospheres. And we call that model Planet WRF. And the version that we use is called Mars WRF, which basically simulates now the environment of Mars.
I didn't expect the model to work for other planets. I thought that it was just an Earth thing. I mean, did you?
Honestly, I'd never really thought about that before, but now that you bring it up, at the end of the day, all this stuff is fluid dynamics, right? It's just a different type of fluid, right? The density of the atmosphere, the type of gases in there. The movement is still based on, standard fluid dynamics. So I would imagine that maybe it's not exactly the same, but it's probably based on very similar principles.
I just assumed everything was different on other planets. It's like physics is different. Newton's law doesn't apply. Clearly, I am a genius.
If that was the case, boy, would it be hard for us to research anything, because we'd have no reference point. Like, we would be like, well, it's completely different than here. So the only thing we know is that it's not the same.
Yes. If I would have given this maybe like a second of thought, I could have reached a more intelligent conclusion.
As a human being, I would have just been like, never mind, I'm going to go do something else.
There's a Venus WRF, there's a Titan WRF, there's a Pluto WRF. So all of these models are out there being used by different research groups to simulate the atmospheres of other bodies out there. Because the physics of atmospheres and atmospheric motion, it's all the same.
No matter which planet.
Doesn't matter which planet you're on. The underlying physics are basically the same. So
like differences in gravity and whatnot, like that doesn't come into play at all?
That does. So you care about things like the gravity, the composition of the atmosphere, how thick the atmosphere is. But the equations like F equals ma, the Newton's laws of motion and things like that, that's all the same. It's universal. So
awesome.
All of the algorithms in the model are basically identical from version to version. It's just what we call the physics, the physical parameters of the model that need to be adjusted.
And for a typical Mars Wharf run, Michael and his team ran the model at about 5-degree resolution, meaning that there's like a data point for every 5 degrees of latitude and 5 degrees of longitude. And then they would typically use 64 cores or so at a time.
So maybe 4 to 5 hours, we can do a full Mars year at that scale.
And they'd usually run simulations for what it would have been like on Mars for 10 to 20 years, which, thanks to high-performance computing, could typically be simulated in less than a week.
Right, and that's not a crazy amount of compute compared to some of the other projects that we've looked at or people we've interviewed.
Yeah, like some of the COVID research that took up like a quarter of some of the biggest supercomputers on Earth, right?
Right.
I've compiled this model on my laptop, and the thing runs just fine. It's, of course, a lot slower.
Just a hair.
Instead of 5 days, it might take you, 50 days, or it may take a couple months to do the whole model. Plus, these supercomputers are really stacked. So they've got a lot of memory, a lot of bandwidth, allows them to communicate very quickly with each other. And because the models are so computationally intensive, you need all that memory.
Yeah, that's absolutely true, right? And that's really, really where the supercomputing comes into play here, in that having all of the memory and bandwidth available in one run, right? As opposed to, even the most powerful of desktop PCs, like a high-end desktop, a Threadripper or something, it's a powerful machine and it's going to do well, but it's never going to be able to keep up with a cluster of machines that are specifically designed to work as a team.
In my mind, these types of climate models are like the perfect use case for supercomputers, because 20 years ago, 30 years ago, 40 years ago, when climate models were first being developed on the most primitive computers, they were very, very basic, and they provided a good deal of insight. But as we kind of develop the technology and the computers become faster, and now we're networking computers together and doing these high-performance computing clusters, we can convert a whole planet from looking at maybe a dozen different points on the surface to one where we could be looking at 100,000 points on the surface, and each point represents, a small fraction of the surface. So you get this incredibly high resolution, and it allows you to sort of solve these problems that were unthinkable 20 years ago. When I started in this field, when I started doing my first work maybe 20 years ago, one Mars year would take 2 to 3 days, what now takes about 5 hours. So just the speed of the computers, the size of the computers, it makes it so much more efficient. And it's just such a great example of how a problem can scale to these large sizes.
And not only is simulating weather on Mars important in helping us learn about the past, but aside from his study, Michael also worked on the NASA team that was responsible for forecasting the weather for the latest Mars rover landing.
The tension inside mission control as real as if this were a human mission. Watching and waiting as 127 million miles away, Perseverance was in its final fiery descent through the thin Martian atmosphere.
We needed to predict what the winds were like, what the surface pressure was like, the temperature and all that.
So I remember watching the landing live as it went on, and I hadn't even considered that weather forecasting had been done. So I can imagine that if you were responsible for the weather forecasting that ultimately impacted the atmosphere as this thing came in,
oh man,
you were on pins and needles hoping that your predictions were right.
Perseverance has now slowed to subsonic speeds and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface.
We were a little on pins and needles hoping that, what we forecasted really panned out. And it turns out it pretty much did. We had a lot of good tools and a lot of good scientists working on the problem, so we pretty much nailed it.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
Soon, Perseverance will drill into rock and soil, searching for evidence of ancient microbial life.
And after the landing, his weather forecasting work actually isn't finished.
The dust storms are probably like the most dramatic type of weather that you get on Mars.
In fact, Ernest, have you ever been in a haboob?
I have no idea what a haboob is, but...
something I know that you don't! Woo! that's not film related.
But from the context of the interview, I'm guessing it's some kind of dust storm.
You are correct.
And I've been in some serious dust storms in Texas, yes.
I wonder if they're in Texas. I know they're in Arizona. So for those who haven't seen one of these, there are these huge, intense dust storms, and they look like this ginormous, creepy wall of like supernatural sand that engulfs everything in its path.
Okay, I know what you're talking about now. That they use one of those in the Dogecoin meme.
Yeah,
Yes.
it's kind of like the clouds on the movie Independence Day right before the alien ship emerges, you know, like those haunting looking clouds, except it's all dust and sand and it's closer to the ground. And there's no alien ship. I should throw that in there. Yet.
Right, we keep bringing the aliens back into this
I
discussion.
know, poor NASA.
Aren't you coming, David? No, I gotta see this.
So I haven't been in a haboob, but my brother was caught in one in Phoenix while he was moving all of his belongings in the back of an open bed pickup truck.
Oh my gosh. Oh my gosh. Oh, my stuff! No!
And while these haboob-type dust storms only happen on Mars, I guess every 3 years or so, apparently they're pretty intense.
It's an amazing sight to see. You actually can't even see the surface of Mars from spacecraft orbit. It's that thick. Nobody has any idea why those happen.
These storms can be so massive that they can even cover the entire planet with like a 15-mile high cloud of this tiny powder-like sand. So if you thought about being instantly burned to a crisp while suffocating in below freezing temperatures as a bad way to go, imagine that happening during a dust storm so large that it blocks the view of the planet's surface from space. So note to self, don't go to Mars. But in the meantime, the Perseverance rover is allowing us to explore the red planet without being there at the moment. And it even brought with it a 4-pound, 19-inch tall passenger.
Yes, you must be talking about the helicopter Ingenuity.
I am.
Celebration this morning at JPL Mission Control. Stunning images just coming in as NASA yet again pulls off the unbelievable, flying a 4-pound autonomous chopper, a drone really, on another planet.
Ingenuity was specially designed to fly in Mars' low gravity and incredibly thin atmosphere. So we're talking 1% the thickness of the atmosphere on Earth, which actually makes me think, I mean, guaranteed they had to design this thing using computational simulation, don't you think?
Absolutely. And so anybody at JPL, I guess it's JPL, right, who helped design that thing, we'd be happy to have you on.
Reach out.
This helicopter, its original primary purpose was to demonstrate that flight could occur on Mars.
Well, check the box. It worked.
It worked, and that was basically it. If it just flew one time and we were able to show that the helicopter could get lift, it could move to and fro and go up and down, that would have been satisfactory because it would have allowed us then to start developing more sophisticated aircraft to allow us to do more exciting things. We could explore places on Mars that we can't get to with rovers and all sorts of things like that. Today, what we're doing is we're actually, now that we demonstrated that and we checked that box, the purpose of the helicopter is to serve as sort of an advanced scout for the rover. So we will fly in the air, about 10 meters high. We fly forward ahead of where the rover is, take pictures of the surrounding area, and then land. And then those pictures can be assessed for interesting locations that the rover may wish to go to. It can identify potential hazards that the rover might have to negotiate.
So they were just hoping it would get lift and be able to fly once on Mars, but instead it's flying so effectively that it's now enhancing Perseverance's mission.
Yep.
The helicopter has performed exceptionally well. We've had 7 flights under our belt right now. And it's a testament to the amount of work that's gone into this thing that it's been able to operate as it has.
In the meantime, Michael and his team at NASA keep their fingers crossed that Ingenuity and Perseverance don't get hit by some of the weather that actually can't be predicted.
You can see many pictures from the rover of dust devils, which are sort of like mini tornadoes in the distance, and they can't be predicted. So it's not like we can control where they are or avoid them to any great extent. But That's our biggest worry, right? Is we
That's
fly and then,
interesting, yeah.
you know, a little dust devil happens to be in the wrong place at the wrong time and blows us away. But we've been lucky so far.
So time will tell, but so far, so good. Knock on wood. And who knows, maybe one of these days we'll pick up some proof that life did, in fact, exist somewhere on Mars, or maybe somewhere else.
I subscribe to that idea that, you know, the universe is so vast that there has to be life somewhere in it, apart from Earth. Whether it's as close as a planet like Mars, or under the ice of one of the moons of Jupiter or Saturn, or whether it's light years or light millennia away, it seems like it has to have taken hold somewhere else.
It's one of the reasons that science like this is so important, right? Looking at other planets, looking at other galaxies, because that's the only way that we're going to figure out, are we truly alone, or are there others that we could perhaps interact with sometime in the future?
Yeah. Oh my gosh, there's so much to think about there. And before we wrapped our conversation, Michael blew my mind with this.
In our solar system, the sun is like the biggest gravitational body, and it's much bigger than everything else. So things flow in towards the sun. Now, people wonder, you know, could life on Earth have transmitted itself to Mars? You know, could an asteroid have hit Earth and ejected material that then traveled out to Mars, and then it landed on the surface and
was able to live?
Microorganisms were able to live. Well, possibly, but wouldn't it be more logical for something to have come from Mars and then been tugged in to Earth?
Oh my gosh, how crazy. That's a crazy thought.
Maybe life on Earth originated on Mars. This early Mars that had oceans and lakes and rivers, and you had microorganisms and bacteria or you know, something like that. And then an asteroid hit, created one of the big craters on the surface. That material landed on Earth, and Earth developed life. And then poor little Mars was out there, and it dried out, and it got cold, and the life disappeared. So maybe we are all Martians.
That's crazy! Mind equals blown.
Yeah, that's definitely an interesting hypothesis of whether or not life from one planet made it to another planet. It reminds me of the, you know, panspermia theory that life exists floating around in the universe, and when it lands on planets and has the ability to survive, it then,
like a dandelion seed in the universe.
Sort of. And for all of our listeners, if you don't know what a tardigrade is, go look it up. They're awesome.
We think we learned how you could have had liquid water on Mars for a long period in its history, and that liquid water could have allowed life to have evolved and flourished on Mars long ago. That's the great part about science, right? There's always more to learn, and there's always more to discover. So this is just a small little blip in the larger sphere of scientific exploration, but this is a really interesting, and frankly, I mean, I agree, this is an exciting area of research where we're really learning a lot more about our neighbor there, Mars, and whether there could have been life, and what it takes to get life to exist on a planet like that.
To learn more about Michael and his work, you can visit
science.jpl.nasa.gov and search for me, Michael Mischna, and you'll have information about the work that I do at the lab, and you can put in anybody's name or any research project that you want and learn an incredible amount of interesting planetary science that's going on at the lab.
We'll also post a link to their research article in the episode notes of bigcompute.org.
It's called Warm Early Surface Enabled by High Altitude Water Ice Clouds. And you can find links to pictures, videos, and articles we've referenced during this episode also on bigcompute.org.
And as always, if you like what you hear, please tell a friend about us, post a review, and subscribe, and rate us on Apple Podcasts.
Or Google Podcasts, or both. Whatever.
Or Spotify.
And I mean, if you operate a skywriting business, you could consider writing bigcompute.org in the sky above a popular beach.
That is super random.
Hey, we don't discriminate on how our listeners spread the word.
That's true. Thanks for joining us, everyone, and always remember to use multi-factor authentication and 3-2-1 backup.
Stay safe out there.